Demand forecasting begins with understanding the various demand channels through which customers purchase products and services. Organizations typically operate within business-to-business, B2B, and business-to-consumer, B2C environments, each possessing distinct demand characteristics. B2B demand often involves larger order quantities, contractual relationships, longer planning horizons, and collaborative forecasting processes. B2C demand tends to be more volatile, influenced by consumer preferences, promotions, seasonality, and market trends. Demand channels may include direct sales, distributors, retailers, e-commerce platforms, service networks, and strategic partners. Understanding these channels enables organizations to gather accurate demand information and develop forecasting approaches tailored to customer behavior. Effective demand channel analysis supports planning accuracy, customer service, and resource utilization. Independent demand represents customer demand that originates outside the organization and is not directly related to the demand for other items. Examples include finished goods, service parts, maintenance supplies, and customer replacement products. Independent demand is influenced by market conditions, customer preferences, economic factors, promotions, and competitive activities. Because organizations cannot directly control this demand, forecasting techniques are required to estimate future requirements. Sources of independent demand include customer orders, service contracts, vendor-managed inventory requirements, intercompany transfers, donations, internal usage, and replenishment orders. Accurate evaluation of independent demand is essential because it serves as a primary input to demand planning, sales and operations planning, S&OP, inventory management, and master scheduling activities. Dependent demand differs significantly because it is derived directly from the demand for other products and components. Rather than being forecasted independently, dependent demand is calculated using bills of material, production plans, and material requirements planning, MRP systems. Components, subassemblies, fabricated parts, and raw materials typically experience dependent demand because their requirements are determined by the quantity of finished products being produced. While independent demand requires forecasting, dependent demand relies on mathematical calculations driven by production schedules. Some items may experience both demand types simultaneously, such as service parts sold directly to customers, while also being used in production assemblies. Understanding the distinction between dependent and independent demand improves planning accuracy and inventory management effectiveness. Forecasting is the process of estimating future demand based on historical data, current market conditions, and anticipated future events. Effective forecasting supports strategic planning, S&OP, master scheduling, capacity planning, procurement, and inventory management. Forecasts vary according to planning horizons, time buckets, and levels of aggregation. Long-range forecasts support strategic decisions, such as facility expansion, product development, and market growth initiatives. Medium-range forecasts support tactical planning activities, while short-range forecasts guide operational execution. Forecasts are generally more accurate when developed at higher levels of aggregation and over shorter planning horizons. Organizations must carefully define forecast horizons and time buckets to ensure that forecasting outputs align with planning requirements and decision-making needs. The forecasting process follows a structured sequence of activities designed to improve accuracy and consistency. Organizations begin by defining forecast objectives, identifying demand drivers, collecting relevant data, and selecting appropriate forecasting methods. Historical demand data, market intelligence, customer information, economic indicators, and operational constraints are analyzed to develop forecast estimates. Forecasts are reviewed, adjusted, communicated, monitored, and continuously improved through feedback mechanisms. Different manufacturing environments require different information inputs. Make-to-stock environments emphasize demand forecasts and inventory replenishment. Assemble-to-order environments require product family and configuration forecasts. Make-to-order environments focus on engineering detail and customer-specific requirements, while engineer-to-order environments rely heavily on engineering capacity estimates and historical project data. Each environment requires forecasting information tailored to its operational characteristics. Forecasting methods are generally categorized as qualitative or quantitative. Qualitative forecasting relies on judgment, expertise, market knowledge, and customer insights when historical data are unavailable or unreliable. Common qualitative techniques include executive opinions, sales force composites, Delphi methods, market research, and customer surveys. Quantitative forecasting relies on mathematical and statistical analysis of historical data patterns. Selecting between qualitative and quantitative approaches depends on factors such as data availability, forecast horizon, product maturity, market volatility, and organizational objectives. Qualitative methods are particularly valuable for new products, emerging markets, and major market changes, while quantitative methods are effective when sufficient historical data exist. Many organizations combine both approaches to improve forecast accuracy and decision quality. Pyramid forecasting integrates both qualitative and quantitative methods to ensure alignment between detailed product forecasts and broader business objectives. In this approach, sales and marketing forecasts are developed at lower organizational levels and then aggregated upward for review by management. Senior leadership evaluates whether aggregated forecasts align with strategic plans, financial objectives, and market expectations. Adjustments may then flow downward to reconcile operational forecasts with business goals. This two-way process combines detailed market knowledge with executive judgment, creating greater organizational alignment. Pyramid forecasting improves forecast consistency across planning levels and reduces the likelihood of disconnected forecasts. It also supports communication among departments and enhances coordination between strategic planning and operational execution activities. Quantitative forecasting techniques include intrinsic and extrinsic methods, each serving different forecasting needs. Intrinsic methods rely exclusively on historical demand data and include time series techniques such as moving averages, exponential smoothing, trend analysis, seasonality analysis, and time series decomposition. Extrinsic methods incorporate external variables that influence demand, including economic indicators, market conditions, weather patterns, demographics, and promotional activities. Associative techniques analyze relationships between demand and external drivers to improve forecast accuracy. Advanced data analytics further enhance forecasting by leveraging machine learning, predictive modeling, artificial intelligence, and large datasets. When selecting forecasting methods, organizations evaluate criteria such as forecast accuracy, cost, complexity, data availability, responsiveness, stability, and ease of use. The most effective forecasting systems balance analytical rigor with practical business requirements and decision-making needs.